Hi, we're going to look at polynomials and really just the terminology and an intro into what they all are and how to handle them. So we have different types of polynomials. First type is called a monomial. Mono meaning one. We have one group. Now that one group could be multiplied or divided, doesn't matter. As long as the number, the variables, whatever you have there, it's just stuck together in one group. That's monomial. The second that you add a plus sign or a minus sign in the middle of your groups, we now have something called a binomial. Bi meaning two. The two groups are being separated by either a plus or a minus sign. Again, you can have multiplication or division, it doesn't matter. But two groups, binomial, and that's two monomials. Now a trinomial, the word tri meaning three, we're going to have three groups. Those three groups are being separated by pluses and minuses. Okay. Again, trinomial made up of three monomial groups. And after that, we have these special names for one group, two groups, three groups. But once you get to 4, 5, 6, 7 groups and so on, we don't have a specific name for them. We just call that polynomial. So anything with 1, 2, 3, 4 groups or more, we just say polynomial. Plain old, there's no special name for it. Now, each one of these types of polynomials, we can classify, we can describe them by the degree or by the exponent, the highest exponent in there. So anything with a degree of 0, so you have a plain old number, any number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, negative numbers, -1, -2, -3, -4, they don't have exponents. They're just constant numbers. So anything with a degree 0, no exponent, we call them constant. Anything with an exponent of 1, so y equals mx plus b, anything in that slope-intercept form, anything with just one variable, we call linear. Anything with a degree 2, an exponent of 2, something called a quadratic. If you remember, these are going to be like those U-shaped graphs, those parabolas. Anything with a degree of 3 is something called a cubic polynomial. And here's where things get a little weird. 4 and 5. 4, we have a name quartic, 4 quarters, quartic, and 5 quintic. And now, once you get past 5, and even you don't really see these too often, but when you get to 6, 7, 8 degree, an exponent of 6, 7, 8, or so on, we don't have there are special names, we don't usually call them by that, but we just say 6th degree, 7th degree, 8th degree, and so on. Now I left a space up here because what about if we're following these numbers, what if we have a negative exponent? Well, never allowed to have a negative. There is no name. Never allowed, we can't do it. So if that's the case, we don't have a polynomial. Now let's take these and come over here and let's describe them by degree. So my monomial, now when I say degree, all of these go just to the variable. So my first group, I have a 5, I have an x. I only care about my exponent for the x. Since there is no number there, it's a magic 1. That magic 1 we say is linear. Coming down to this binomial, I'm looking at, I have two groups here. I'm looking for the one with the highest exponent with the variable. No variable here, ignore it. I'm looking at the 5x. That group, just the exponent, has an exponent of 1. We again call that a linear function, linear polynomial. Next, we have three groups here. I want to look for the highest degree, the highest exponents in each group. Here, I don't have anything. Here, I have an exponent of 1. Over here is where it gets a little tricky. I have an exponent of 2, but that only goes for the y. For the x, I also have an exponent, of 1. Now, when you have a monomial and multiple variables, you're looking at the total of the exponents of everything in that one group. So this technically is a degree 3, and it's a cubic because you have the x has 1, the y has 2, add them together to give you the 3. The last polynomial down here, you have exponent of 1, exponent of 3, and an exponent of 5. I want to go for the highest exponent. This is a degree 5, and we call that a quintic. So that's all just definitions to understand what a polynomial is. Now, let's talk about something called standard form. Standard form, you see it all the time in algebra. Means a ton of different things, but when we're specifically talking about polynomials, standard form means reordering your problem so you have highest exponent down to lowest exponent. Okay, so like over here, how I kind of drew a little box under each monomial, under each group, I want to do the same thing. Now, every time I do it, I want to make sure that I include the sign, the negative or the positive sign with the number. So I have three groups here. Let's put them in order. Highest exponent to lowest exponent. 4, 2, nothing. I want this first. Negative 4x to the fourth. We used it. X squared. Now I need a sign to separate these. Since this leads everything off, there's no sign. I know that it's plus. Put a plus sign in there. We used it, and then minus 3. Standard form just means put it in order. Highest exponent to lowest exponent. Okay, once we do standard form, you can then answer a ton of information that usually goes along with this. Leading coefficient. Coefficient means number. What's the leading number of my standard form? Now, in this case, negative 4. I never want to go back to my original problem because we didn't do anything with it. It's not correct yet. What type of polynomial? Well, we have 1, 2, 3 groups. Over here, 1, 2, 3 groups. We call that a trinomial. The degree, my highest degree of exponents, so we have a 2 here, we have a 4 here. We're going to call that degree 4, and then name it by degree right next to it, quartic. Now, there are some things that we are not allowed to have. The things that we are not allowed to have, again, a negative degree. Can't have it, period. Now, with a negative degree comes a few other possibilities of what's not allowed to have. So we have one more problem here. And I want to know, is it a polynomial? Well, short answer, no, it is not. Long answer, why? Well, we are not allowed to have a negative exponent, period. We just said that back here with our charts. Well, what about that y? Well, the y is in the bottom of the fraction. Now remember, when you have a variable on the bottom of the fraction, if you want to move it to the top, they switch positive to negative. So if I were to move this back up top, that would end up being a negative 1 exponent. So we can't have that. So no, no. And then finally, we have that negative 5 to the z power. That z power, a variable. A variable means literally any number. That could be a positive 2, positive 3, positive 4, positive 5. It could be any of those numbers. But it also could mean negative 1, negative 2, negative 3, negative 4. So because it's an unknown and we don't know it, it could possibly be a negative. So again, because of that, we're not allowed to have. And this is an intro to polynomials and just definitions. So thanks.